Daniel Hines from Raytheon. Daniel is going to talk to us about printed hybrid electronics manufacturing, pathways to next generation electronics. Daniel.
Thank you. I would like to thank the organizers for the invitation to come and talk with you all. I want to thank the gentleman who just got everything all set up. See if I can follow that act. Very, very nicely done there on the spare of the moment with everybody watching. So I want to start off by giving an introduction to our institute, Raytheon UMass Lowell Research Institute. I'll talk a little bit about some board level printing architectures that we're working on there and some printed interconnects. And then I'll finish up with presenting to you what I think some of the hard topics are in this area and some of the manufacturability. So we, back in 2014, stood up the Institute as an agreement between Raytheon and UMass Lowell, the university. It's about a 6,000 square foot ITAR facility up on the 4th floor of the Emerging Technologies building on campus. And we have, so we're kind of, we're co-located. We have university professors and their students. And we have Raytheon engineers co-located working together on various research and process development topics. And so, I haven't done any of this work. It's my privilege to present what we've done. I'm the director from the Raytheon side, the director from the university side, Alka McCutlow, back in the corner there. We also have one of our RURI engineers here, Lily Clark. And so, these are the people that have done all the work, and I get the privilege to present some of this. So what we're going to be talking about mostly is direct write printing. And I assume a lot of people in this audience know very well what direct write printing is, but I'll just give a quick introduction. And so, syringe printing and inkjet printing, aerosol jet printing. I won't really go into the details of any of those, but these are the kinds of deposition methods that I'm referring to when I talk about direct write printing. And so, here are a couple of our tools, our 5-axis end script, our 5-axis aerosol jet printing. It's an optomic tool. And so you can see this, 5-axis motion while you're dispensing some kind of an ink, either through a syringe type tip or in an aerosol jet fashion. And so you can see on the aerosol jet, we've got this little bitty, it's an interposer type structure. I'll show it to you a little bit more detail on the next slide. But the idea is to print these jumper connections that wrap around to the back edge. And so in doing that, that gives you this interposer type structure that, you've got this, see if I can use the pointer. Yeah, so I guess I don't know if I have I have a pointer here. So can you see that pointer moving around? Yeah, great. That'll be even easier. All right, so you can see you've got this board level structure with these mimics down in these cavities. And so typically you have to route signal lines around those cavities. But there can be an advantage in area of the board reduction if you could route those lines across over the top of these cavities in the board. And so that's the idea here, where you've got this kind of an interposer, and this is about 6 millimeters square, so it's pretty small, and mounted in this cavity area where you've got these traces, these conducting traces that wrap around and allow you to route these signals over these otherwise open, unused areas. And so, you may think that, 6 millimeters square is a small area, but you think that not only is it the board that shrinks by this amount, and, and how many of these cavities do you have on a board? So, by how many, you're shrinking by the size of how many you have on that. But then you're mounting